Good day, folks. Here's another question on universal gravitational law. It says here two satellites orbiting the Earth. Here, the two satellites, they are orbiting the Earth, they're moving around. On opposite sides of the Earth, satellite A has a mass of 3,800 and satellite B has a mass of 4,500. Satellite A is at a height of what? 25,000. So satellite A, the height is what? From there to there, it's 25k, which is 25,000 kilometers, right? Now, and it says above the surface of the Earth. But one thing that you need to understand that the radius of the Earth is from there to there, and the radius of the Earth is the constant, right? So that's the radius of Earth, and this is the height. You have to convert that height. So 25,000, 25,000 you divide by 1,000, it's going to be 25. So the height now, when you convert it into meters, is 25 meters, right? So guys, this distance from there to there, which is r, it's the height plus the radius of the Earth. It's equal to 25 meters plus the radius of the Earth, guys. It's a constant. It's 6,38 times 10 to the power 6, right? So this is the whole distance from here to here. That's r, right? Now, in 5.2, so guys, another thing, there's a gravitational force. There's a gravitational force between the Earth and the satellite, right? It's very important that. Now, 5.2, it says explain the term weightlessness. When you experience weightlessness, guys, it's when all the contact forces are removed, right? It's when all the contact forces are removed. In fact, it's a sensation. It's like when you enter the lift and then the lift goes down. So what are you going to feel there? You're going to feel weightlessness. So it's a sensation. It's a sensation when all contact forces are removed, right? When you go down, or it's when you throw something or something that is falling, it's going down. So the only force that is active on it is the gravitational force. So that is weightlessness, okay? Now 5.3, it says calculate the force between the Earth and the satellite A. So 5.3, so the force between the Earth and the satellite A is the gravitational force, so it's F is equal to G mass 1 times mass 2 over R squared. So the G times the mass of the Earth times the mass of the satellite over the R, guys, remember it's going to be the height plus the radius of the Earth square. Very important that. I'm going to write there. So let's substitute. So it's going to be 9 times 10 to the power 9. No. It's 6.67. It's 6.67 times 10 to the power negative 11. And then the mass of the Earth is 5.98. You get it from the data sheet, to the power 24. And then the mass of the satellite, we were told the mass of the satellite A. Satellite A has a 3,800. So 3,800. And then we all divide by the height. The height there, it was 25. And the RE, it's 6.38 times 10 to the power 6. And then we square that. If you punch that in the calculator, guys, the answer there, it will be 1,539,23 newtons. That's the force between the Earth and the satellite. That's the gravitational force, right? Now 5.4, it says what distance above the surface of the earth should the satellite be to experience the same force as satellite A. So guys, if you're looking here, we have satellite B. So in order for satellite B to experience the same force, which is the same force is this, that is experienced by satellite A, what is the distance that it should be? So in order to calculate that, that means we need to involve the distance. So we have to say force is equal to G mass of what? F multiplied by the mass of the satellite what? B now. Over, we wanted the height now. So what we're going to do here in R, it's the height plus the radius of the earth square. Guys, we want this height. What is the height? We want this height here, right? But we know the radius of the earth there. So we want the distance that it will be. So when what is the distance? So we want the what? This height. We want from there to there. From there to there, we know already that the radius of the earth. So what are we going to do now? We're going to substitute. We're going to substitute this force because it needs to be this force. What will be the distance if it has that force? So we have to substitute it. 1539,23 equal to 6.67 times 10 to the power negative 11. We times by the mass of the earth, that's 5.98 times 10 to the power 24, and we times by the mass of the satellite B, it was 4,500. Let me double check. Mass of satellite B is 4,500, right? And then we want the height. So what I can do here, I'll say, okay, to make my life easy, instead of finding this, I'll just put R there. I'll just put R square there, and then to make my life easy. So what I'm going to have, it's 1539,23 R square, we divide, equal to, we cross multiply there. So it's 6.67 times 10 to the power negative 11 times 5 times 5.98 times 10 to the power 24. 24 times 4,500, and then we divide by 1,539,23 both sides. 1,500 yes, 23, and then that cancel, and then we're going to put that in a square root. So the answer there, let me punch that in the calculator. It's going to be 6.67 times 10 to the power negative 11 times 5.98 times 10 to the power 24 times 4,500, and then we divide by 1,539,23. So the answer there is 34. It's 34. 3414 comma now 34148214,93 meters. So what is this that I've done? What is this R? The R, what I've calculated is from here to here, right? It's from here to here, including the radius. So now I'm going to minus the radius, so it's going to give me from here to here if I subtract this. So now what I'm going to do now, I'm going to say height is equal to radius minus the radius of the earth. Alternatively, you can say R is equal to height plus RE. So what you have that, and you want that, and you have that, right? So when you take this to this side, you Okay, this is what you want, so we take this to this side, right? So your height is going to be this value, which is, I'm not going to write it again, don't have energy to write it again, so I'm just going to duplicate it, put it here, and then erase that, which is r. You minus what? The radius, which is 6.38 times 10 to the power 6. So in the answer in the calculator, say minus 6.38 times 10 to the power 6, which is the height is, let me put it in the scientific notation, so it's 2.7, 2.78, 2.78 times 10 to the power 7 meters. That's the height where it needs the satellite be in order to get the same force. So this is the height, which is from here to here, is the height of satellite B needs to be in order to get the same force, which is the same force, which is this force as A. Okay guys, the answer here was to choose that is greater than or lesser than or equal to the distance above the earth, or explain how you arrive there. So guys, since we have seen that this distance that it needs to be, it's greater than, because the distance here is 25 meter, and the answer that we got here, it's 2.78, right? Which is the answer here, it's greater than, and then it's greater than, and that's the answer. It's greater than, come on, it's greater than, and then the motivation, it's this whole calculation.